We're going to look at two different types of quadratic inequalities today. The first one has two variables. Notice the first example, y is greater than x squared minus 2x minus 3. And also notice that it's quadratic because the x is squared. So we're going to graph the boundary, where the boundary is a quadratic equation, also known as a parabola. So in order to get the boundary, we need the vertex and two other points. So I know that I can get the vertex, I can make my vertex, get my vertex, by x equals negative b over 2a. So 2 divided by 2 times 1 is 1. So that means my vertex is 1 comma something. So if I plug in 1 squared minus 2 times 1 minus 3, that would be 1 minus 2. Negative 1 minus 3 is negative 4. So I'm going to plot 1 comma 1, 2, 3, negative 4 as my vertex. And I'm going to get two other points, and I'm going to get those two other points by factoring to find the zeros. So I'm going to factor, I'll do it up at the top. I'm going to factor this trinomial, and I'm going to get my zeros, or my x-intercepts, which I see are x minus 3 is equal to 0. Then x equals 3. So I've got a 1, 2, 3 as an x-intercept at 3. And if x plus 1 is equal to 0, then x equals negative 1. So I've got my 3 points on my boundary, and I see that it just says y is greater than. So I'm going to make a dotted parabola as my boundary. And then since it says y is greater than, remember, when it says y is greater than, we shade above. If it says y is less than, we'll shade below. So in this case, we'll shade above. So that's not too bad. We can also look at a quadratic system of inequalities where there are two. And when there are two, remember, we want to only shade the area of intersection. So let's see. The first one, y is greater than or equal to x squared minus 4. So if I do negative b over 2a, that would be negative 0 over 2 times 1, which is 0. So that means my vertex is 0 comma something. And if I plug in 0, 0 squared minus 4 is negative 4. So my vertex for my first inequality is at 0, negative 4. And if I factor x squared minus 4, I get 2 and negative 2. So I see that that's a solid boundary. So I'm going to go ahead and give that one a solid boundary, greater than or equal to. And we also know we need to shade above. So let me change the color, and then we'll graph the second one in blue. So I'm going to do negative b over 2a again. So that's 1 over 2 times negative 1, which is negative 1/2. So this one has a vertex at negative 1/2 comma something. And I think I'm going to go ahead and put that one, let's see, negative 1/2 squared would be 1/4 minus negative 1/2. So that would be plus 1/2 plus 2. Negative 1/4 plus 1/2 is 1/4, and 1/4 plus 2 would be 2 and 1/4. So I'm just getting the vertex. Negative 1/2 comma 1, 2 1/4. This one opens down. So I'm going to factor out that negative to see if I can factor this guy right here. And I think I can get my zeros. Let's see, the factors of negative 2 that add up to 1 are plus 2 and minus 1. So I see that I have x-intercepts at negative 2 and at 1. And this one opens down, so I'm going to make a dotted boundary because I just see less than opening down. So we have this like kind of egg kind of shape made there where the two intersect, because the first one, the red one's greater than. and then the blue one's less than. So we're going to shade in between, like right here. So when we have quadratic inequalities with two variables, we're graphing on the coordinate plane. We're graphing the boundary as a parabola. I want the vertex and I want the two x-intercepts. We factor to get x-intercepts, remember. And then we shade either a greater than or less than, depending on what the symbol tells us. Okay, so the next problem says you're building a wooden bookcase. You want to choose a thickness, D, so D is the thickness of the shelf, so that each is strong enough to support 60 pounds of books without breaking. A shelf can safely support a weight of W in pounds, provided that W is less than or equal to 300 D squared. So W is the weight, and D is the thickness of the shelf. So I don't think we need to graph this inequality. I think we know what it would look like. But let's answer part B. If you make each shelf 0.75 inches thick, can it support a weight of 600 pounds? So I want to know if the weight is 60 and the thickness is 0.75, will it support? So let's see if this inequality is true when I plug it in. I'm going to go to my calculator. 300, go back to the home screen, clear all that. 300 times 0.75 squared is 168.75. So 60 is less than or equal to 168.75. And that is definitely a true statement. Therefore, yes, it can. So we just know that if we plug in an ordered pair, if the ordered pair is true, then it is a solution. And then the last type of inequality we're going to look at for quadratics is a quadratic inequality that has one variable. So these are done a little bit different because we don't graph one variable on the coordinate plane. We graph one variable on the number line. So these are going to be graphed on the number line. So the first thing we have to do is we have to get our boundary. So we get our boundaries. Let's make some steps here. We get our boundaries by finding zeros. Okay, so that's the first thing. First thing we do is we get zeros. So we factor to get zeros, or if we can't factor, then we're going to want to use the quadratic formula. So I'm going to factor this. I know that the factors of 5 that add up to -6 are -5 and -1. So if I set each factor equal to 0, because that's how I find zeros, then I get x equals 5 or x equals 1. So then I'm going to make a number line. So there's 1, 2, 3, 4, 5. Okay, so I'm going to put an open circle at x equals 1, and I'm going to put an open circle at x equals 5. And the reason why I'm putting an open circle, let's make a note of that. We're putting an open circle because just less than. If it was a less than or equal to, then we would want a closed circle. Okay, so then we're going to test some points here. We're going to pick a number. Well, we need to figure out where are the solutions. The solutions are either to the left of 1, in between 1 and 5, or to the right of 5. In other words, less than 1, in between 1 and 5, or greater than 1. Greater than 5, excuse me. So we have to pick some test numbers. So I'm going to pick a number that is less than 1, like 0. And I'm going to plug 0 into the original inequality. And that says that 5 is less than 0, and that is false. So since that's false, the solutions are not less than 1. And now I'm going to pick a number that's in between 1 and 5, like 2. So if I plug in 2 squared minus 6 times 2 plus 5 is less than 0. That's 4 minus 12 is -8. -8 plus 5 is -3. And -3 is less than 0. So I found solutions that are, since 2 is a solution, then everything in between 1 and 5 is also a solution. So I'm going to shade in between 1 and 5. And when I shade in between 1 and 5, it makes me think that I have an and compound inequality here. Now we're going to pick one more number. Pick one more number that is bigger than 5, to the right of 5, like 6. So if I plug in 6 into the original inequality, 6 squared minus 6 times 6 plus 5 is less than 0. 36 minus 36 is 0. 5 is less than 0. That is false. So it looks like my solutions to this inequality are in between 1 and 5. So I have an and compound inequality. So I'm going to say that the solutions are, let's see, x needs to be greater than 1 and also, not greater than, excuse me, greater than 1 and also less than 5. And there's my answer. So I use my graph as a help tool. I use my graph as a help tool to figure out whether I have an and compound inequality or whether I have an or compound inequality. Let's do the one right below it next. Solve x squared plus 2x is less than 8. So the first thing I'm going to do is I'm going to move the 8 to the other side and put it in standard form. Now I'm ready to factor to get my boundaries. So let's see, the factors of negative 8 that add up to 2 are 4, positive 4, and negative 2. So I factored it correctly. And I need to set each factor equal to 0 to get my boundaries. So I get negative 4, and I get 2. So remember, we set it equal to 0. If x plus 4 is equal to 0, then x equals negative 4. And if x minus 2 is equal to 0, then x equals 2. So the next step would be to make our number line to help us. So I'm going to make a number line, and I'm going to put 2 as a boundary. And I'm going to put a closed circle at 2 this time because I see that I have less than or equal to. And I have 1, 2, 3, 4, negative 4, also a closed circle on negative 4. Okay, so now I have to pick test numbers to see where the solutions are. So I have to pick a number that's less than negative 4 and plug it into the original inequality. Like, for example, negative 5. So if I plug in negative 5 into the original inequality, I get 25 minus 10, which is 15, and 15 is less than or equal to 8. That is not true. That's false. And so then I'm going to plug in a number that is in between negative 4 and 2. Like, for instance, 0. 0 squared plus 2 times 0 is less than or equal to 8. So 0 is less than or equal to 8. That is true. So I'm going to shade the section in between negative 4 and 2. And then I'm going to pick a number that's bigger than 2 and plug it in, like 3. So I'm going to plug in 3 into the original inequality to see if I get a true statement. And I get 9 plus 6, which is 15. 15 is less than or equal to 8. That's not true. So it looks like, once again, my solutions are in between the two boundaries. And so therefore, I have an and compound inequality. So I'm going to say x has to be greater than or equal to negative 4 and less than or equal to 2. Now remember, my solution is the inequality. We use the graph, the number line, to help us. Okay, we're going to do this one more time. We're going to go up to this example. And this is the one that doesn't factor. So we remember that if our quadratic does not factor, to get zeros, we need to use the quadratic formula. So I'm going to say x equals negative b plus or minus the square root of b squared, so 3 squared would be 9, minus 4 times a times c, all over 2 times 2, which is 4. So let's see, we get negative 3 plus or minus the square root of, that would be 8 times 3 is 24. So 9 plus 24, which is 33, all over 4. So we get two boundaries, once again. Two boundaries. I cannot simplify the square root of 33. So they're already simplified. So I'm going to make a number line now, and I'm going to put these two boundaries on a number line. The problem is I don't know where they are in the number line. So I'm going to go to my calculator, and I'm going to put the numbers in and approximate. So I'm going to say, all right, I'm going to put in a fraction. Let's see, fraction negative 3. Is that right? I forgot already. Yes. Negative 3 plus the square root of 33 all over 4. That is approximately 0.686. So I'm going to go to my number line, and I'm going to put in 0.686, which is negative 3 plus the square root of 33 over 4. All right, and then I'm going to go back to my calculator, and I'm going to do fraction again, and I'm going to do negative 3 minus the square root of 33 all over 4. And press enter, and that is about negative 2.186. So I'm going to go to my negative 1, negative 2, negative 2.186, which is negative 3 minus the square root of 33 over 4. And I'm going to put close circles on both of those. Close circles because greater than or equal to. Okay, so then I'm going to pick a number that is less than negative 2.186, like negative 3. So I'm going to do 2 times negative 3 squared plus 3 times negative 3 minus 3 is greater than or equal to 0. So let's see. That would be 9 times 2 is 18. 18 minus 9 is 9. 9 minus 3 is 6. 6 is greater than or equal to 0. That is true. So it looks like my solutions on this time are on the outsides. And we can check 0 would be in between. 0, 2 times 0 squared plus 3 times 0 minus 3 is greater than or equal to 0. Excuse me. So we get negative 3 is greater than or equal to 0. That's false. Excuse me. So we don't want to shade on the in between. We want to shade on the outsides. So it looks like we have an or. Excuse me. So sorry. So we have an or compound inequality this time. So I'm going to write it as an or. I'm going to say x is less than or equal to the smaller number, this big nasty thing, or x is greater than or equal to the bigger number. And that's it. So remember, the inequality is my answer, not the number line. All right, good job.